BGP Next-hop Modification in NixOS. In this video, I'm going to talk about how we can configure iBGP or internal BGP and why we need to change the next-hop in the BGP, and after that, I'm going to show you how you can change the next-hop in the NixOS. Don't forget that this feature is explained in the iOS and we should do some different tasks to enable it, but it's similar to the iOS. Let me to start to configure this scenario. In this scenario, we have three AS 65000, AS 65001, and AS 65002. AS 65001 is a transit AS, and we need to connect both two AS 65000 and AS 65002 with the with the transit AS together. Okay, first we should configure one eBGP connection between router switch 1 and switch 2, and then second eBGP neighborship between switch 3 and switch 4, and finally we need an iBGP neighborship because we need to advertise the route received from the switch 1 in switch 2 to other switch, and also the routes received from the switch 4 into the switch 3 to other switches. Okay, because of that we need to configure iBGP. First we should start with configuration of the IP addressing in this scenario, and after that we can go further, and after that finally we should configure the BGP. Let me to start from the switch 1. This is the NixOS 1 or switch 1. I'm using the conft command. Okay, the host name is switch 1, and after that first we should enable ETH11 with IP addresses. The first command is no switch port. Now it's a routed port. The second command is IP address 10.1.2.1, so easy, /24, and finally no shutdown. That's it. Then we have another loopback interface loopback 0. The IP address of loopback is quad 1/32, and finally we can check to show IP interface brief. Yes, we have to enable interface. Let's go to the router to the switch 2. This is the switch 2, conft hostname switch 2. We have two interface ETH10, ETH11. No switch port is the first command. IP address is the second command. IP address 10.1.2.2/24, and after that no shutdown. Again, interface ETH12. IP address is 10.2.3.2/24. We should first enable the routed port, no switch port, then IP address 10.2.3.2/24, finally no shutdown. Show IP interface brief. Look at here, we have again two enabled interfaces. Let's go to the switch 3. In switch 3, conft hostname is switch 3, and then we have interface ETH11. First we should enable the routed port, no switch port. IP address is 10.3.4.3, the IP address of the ETH11/24, and then no shutdown. Again, interface ETH12. IP address is 10.2.3.3/24. First no switch port, IP address 10.2.3.3/24, and no shutdown. Show IP interface brief. Okay, we have to enable interface. Finally, we should configure the switch 4. It's easy. Then host name is switch 4, and after that we have ETH11. First no switch port, then IP address is 10.3.4.4/24, and finally no shutdown. Okay, again interface loopback 0. IP address is quad 4/32. Okay, show IP interface brief. As you can see, we have to enable interface. The next command we need to configure is the enabling the BGP with feature BGP. Let me to configure the feature BGP on all switches. First, you should configure this command, feature BGP. If you don't enable the feature BGP, you can't configure the BGP. Okay, feature, for example here, feature BGP, the switch 3, and after that in switch 4, feature BGP. So easy. Okay, let me to configure BGP first in NX-OS1 and NX-OS2, or switch 1 and switch 2. And this is an eBGP neighborship. So easy. Router BGP in the switch 1. I'm using the router BGP 65000. Okay, it's better, it's recommended to configure the router ID with the BGP, with the router ID command, router ID quad 1. Then we should enable the address family IPv4 unicast, and also we should advertise the loopback IP address net for quad 1/32. Okay, after that we should configure the neighbor. The neighbor is 10.122. Okay, the remote AS of the neighbor is 65,001. Okay, and after that we should enable advertisement of address family IPv4 unicast for this neighbor, address family IPv4 unicast. That's it. This is the configuration needed in the NX-OS1. Okay, let me to configure the NX-OS2 or switch 2 for BGP, router BGP 65001. First we should give this process a router ID. This is optional, BGP router ID quad 2, and then enabling address family IPv4 unicast. After that we should configure the neighbor. The eBGP neighbor is 10.121. The remote AS is 65,000. And after that, you know that we should enable address family IPv4 unicast to this neighbor. Okay, now we should have neighborship between these two routers. Do show BGP IPv4 unicast summary shows us that we have neighborship, and also we receive one pass from the switch 1. Let me to check. Do show BGP IPv4 unicast. This is the BGP table of the switch 2, and as you can see we receive quad 1/32 with the next hop of, for example, 10.121, the IP address of the switch 1. Now again we should advertise this pass from the switch 2 to the switch 3. This is an iBGP neighbor. Let me to configure the iBGP neighbor between switch 2 and switch 3. In switch 2 we need only to configure another neighbor. The next neighbor is 10.233, and then the remote AS is 65,000. Also we should enable address family IPv4 unicast for this neighbor. That's it. Let's go to the switch 3. In switch 3 I'm using router BGP 65001. router ID is quad 3, for example. After that address family IPv4 unicast now is enabled, and then we should configure the neighbor 10.232. After that remote AS is 65,001, and finally we should enable address family IPv4 unicast to this neighbor. After some seconds we will have the neighborship between switch 3 and switch 2. Do show BGP IPv4 unicast summary. Okay, as you can see we have neighborship between switch 3 and switch 2, and now switch 3 also receive one route from the switch 2. Do show BGP IPv4 unicast. Look at here. Here we have quad 1/32, and this is this pass received from an iBGP neighbor. But you can see here an angle bracket. Why? You know that because the next hop is inaccessible for the switch 3. When a route received from the eBGP peer, and that route should be advertised to an iBGP neighbor, by default next hop doesn't change. Because of that, switch 3 doesn't have the pass to the for example 10.120, and it can't use this pass. If you want, you can check to show BGP IPv4 unicast for quad 1, and here you can see that this is an inaccessible pass. Because of that, the NX-OS3 cannot use this pass. You should change the next hop as you did in the iOS. Okay, for changing the next hop in NX-OS, you can use next hop self command under the address family, under the neighbor, a specific neighbor. For example, in the switch 2 I'm using this command for the neighbor 10.233 next hop self. Okay, next hop self. So easy. After that, NX-OS2, when it wants to send quad 1/32 to the NX-OS3, should change the next hop of this pass from the 10.121 to the 10.3 10.2.3.2, the IP address of the NXOS2. Let me to check again switch 3. In switch 3, do show BGP IPv4 unicast. As you can see now, next hop is changed, and also we have the angle brackets. So easy. And this